Hello everyone, in this video, chapter 5, lesson 1, we are going to talk about bisectors of triangles, like angle bisectors and perpendicular bisectors. The first theorem in the lesson is about perpendicular bisector theorem. So this theorem tells us that if we have a point on the perpendicular bisector of a segment, so here is how the perpendicular bisector look like, by the way. Segment FK, it is perpendicular to this segment and it cuts it in half. This leads us to this. Segment FK is a perpendicular bisector of this triangle. So when we have this kind of segment, any points on that segment, point F, point K, just plot a point here. The distance between those points and the endpoints of the segment must be the same. That's what it says. It's equidistant from the endpoints of the segment. So let's look at example 1. Find the measure of segment FM. In this example, point F is on the perpendicular bisector. Point F is on this segment. So the distance from point F to G must be the same as the distance between point F and M. These two must be congruent to each other. So that's why the length of segment FM must be 2 point A, the same as this. The second example, what we have in this example is a perpendicular segment BD is the perpendicular bisector of segment AC. So let's look at it closely. Segment BD is right here. It's given that it is perpendicular bisector of segment AC, which means it must be perpendicular, just like that one. It's given already. And it must cut the segment AC in half. So if segment AC is this, and if it's cut in half, this side must be the same as that side. And we have their measures. One half is 5x minus 6, the other half is 3x plus 8. This is one of the common questions that I get. They look different. How do we know if they're equal? So the theorem tells us that if you have a perpendicular bisector, any point on that perpendicular bisector must be equidistant from the endpoints of that segment, like point D. That distance must be equal to this. Even if they look different than each other, they must be equal. So let's set them up equal to each other. Subtract 3x on each side. 2x minus 6 equals 6. Add 6 on each side. 2x equals 12. If we divide by 2, we get x equals 6. So the question was about finding the x. So we are done with the question. Before I move on, I want to go over these two theorems as well. If a point is equidistant, converse of perpendicular bisector theorem. This is going to be exactly the opposite of this one. If you have a point equidistant from the endpoints of a segment, like if you have a point, let's say this point, okay? If that one is equidistant from the endpoints of any side, like let's say these two, then this point, let's say point D, must be on perpendicular bisector. So we can imagine that there is that segment which is perpendicular bisector. The last one, Circumcenter Theorem. This one tells us that the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. So let's just draw a figure that represents this theorem. Let's say we have this triangle ABC, and it will have 3 different perpendicular bisectors. Let's say for point B, segment BC, this one cut the segment in half in 90 degrees. And let's say for segment AC, it's going to start from point B. Let's say this is 90 degrees and the sides are the same. And this one here cuts it in half with 90 degrees. So this means, let's do the rest of it. That is equidistant from the vertices of the triangle. So this point right here, let's say point D, must have the same distance from the vertices of the triangle. If AD is 10 units, BD must be the same, CD must be the same. So they all must be equals. If one of them is given, just put the same expression or the number or value, measure, whatever you call it, to the others. They're going to be equal anyway. So let's to angle bisector theorem. So this theorem tells us if a point is on the angle bisector, then it is equidistant from the size of the angle. This time, it's not going to be equidistant from the vertices of the triangle. It will have the same distance from the sides of the angle. Now, let's look at the first example here. It's going to make more sense when we look at the example. Ray MR is the angle bisector of angle NMP. So let's just focus on these two parts of the triangle. Ray MR is the angle bisector. Now we know that this ray cuts the angle in half, and that angle is this one right here, angle NMP. Angle NMP is right here. This part of the question tells us that purple ray cuts the angle in half, which means angle 1 right here and 2 are equal to each other because that one cuts the angle in half. Now let's see if we know anything about those angles, like angle 1, measure of angle 1 and measure of angle 2. They are given, and we also know that they are equal. Even if they look different than each other, since we know that they are the same, they must be the same, we set them equal to each other. 8x minus 16 equals 5x plus 8. Subtract 5x on each side. 3x minus 16 equals 8. We add 16. 3x equals 24. Divide by 3 to get x equals 8. Let's see if we need to figure out a measure of an angle. But no, we need to figure out what the measure of angle x is. So what the measure of x is, we figure that out. That means we can move on. But before that, please remember that the converse of angle bisector theorem means if a point in the interior of an angle is equidistant from the size of it or the angle, then it is on the bisector of the angle. So if you have a point, let's say we have a triangle here, interior, let's say that point. If this point is equidistant from the sides, here we have one side and this one. If these distances are the same, then this point must be on the bisector of the angle. So this point is on that segment, so this segment must be an angle bisector. These two must be equal to each other. That's what it says. The last one, Intersect theorem. The angle bisectors of a triangle intersect at a point called the incenter that is equidistant from the size of the triangle. So the example about this theorem is going to be in the next slide. Here we have two examples. So the first one, let's start with the first one. We need to figure out the measure of angle MYW. Let's see what that angle is. Angle MYW. It's given as 2x plus 5. First we need to figure out what x is, and then we need to plug it in for this. If you look at the question carefully, we have a point M which is equidistant from the size of an angle. 90 degrees, 90 degrees, and the measures are the same. We have a point which is equidistant from the side of an angle. Let's look at converse of angle bisector theorem. If a point like M in the interior of an angle is equidistant from the size of the angle, which is what we have, then we need to have this fact. It is on the bisector of the angle, so this point must be on the angle bisector. It's on this ray, and that ray must be angle bisector of this angle, which means 4x minus 1 and this measure must be equal to each other. 4x minus 1 equals 2x plus 5 because ray YM cuts the angle in half. Subtract 2x. 2x minus 1 would be equal to 5. If we add 1 on each side, 2x equals 6. Divide by 2, x equals 3. This is not done yet because we need to plug this in to get the measure of that angle, 2x plus 5. So if x equals 3, 2 times 3 plus 5 would be equal to 11. The last example, we are given that point A is the incenter of triangle PQR. Find each measure. So let's focus on point A. it says this point is the incenter. This point is the incenter. That means this is where all the angle bisectors meet at. That means angle bisectors start from the angles. QA is an angle bisector. Whatever that angle is must be equal to this. These two angles must be congruent. And also same thing applies for this. P starts from the angle. PA cuts the angle in half, which means these two are congruent measures. And also angle segment AR cuts that angle in half. And this point A must be equidistant. This point A must be equidistant from the sides. These three measures are congruent. Now let's see the measures that we need to figure out. The first one, measure of angle ARU. Let's see what that angle is. Angle ARU is right here. This corner and that corner must be the same. These two angles. Because that is an angle bisector, so it's 40 degrees. Measure would be 40. Next question. Segment AU, the measure of segment AU, or the distance between those 2 points. AU is right here. This is the same as that, which is 20, and also this one is going to be 20 as well. So it's 20. And the last one here is measure of Q, angle QPA. Angle QPA is right here, which is 3x plus 2. So this question is actually about what is 3x plus 2. But first we need to figure out the x by using these two measurements because they are the same. Remember, PA was the angle bisector right here. This one cuts the angle in half. So the left side of that angle must be equal to the right side of it. 3x plus 2 and 4x minus 1 minus 9 must be the same. Subtract 3x. 2 equals x minus 9. Add 9 on each side. X equals 11. Now, since we know what x is equal to, we can figure out 3 times x plus 2, 33 plus 2, or 35. Now, please comment below if you have any questions. Thanks for watching. See you in another video.